In this video, we are going to do these three questions from the chapter Similar Triangle Class 10th. And we'll be using BPT, that is Basic Proportionality Theorem. It's converse, and also to prove triangle similar when using SAS or AA, and writing their sides proportional when two triangles are similar. So let's begin with the working of the first question. In this question, we are given a figure and the two triangles ABC and DBC are drawn on the same side. So that is BC is the common side where two triangles are drawn. One is what? This is triangle. Two triangle. One is what? ABC, right? This is triangle ABC. And the other is triangle DBC. All right. This is the first information we have. Further, it says that PQ is parallel to, this is PQ. PQ is this, right? This is drawn parallel to AD. These two are given parallel. And the other information we have is PR parallel to BD. So we can see where is PR. This is PR. PR is drawn parallel to BD. Well, this is already marked over here. You can see in the diagram, the parallel is being marked over here, that this is drawn parallel to this. Now, what we need to prove over here in the final part is to prove QR is parallel to AD. This is QR parallel to AD. These two lines we have to prove parallel. Well, this is very clear from this kind of question information when we apply BPT. So let's use the first information here. I'm going to use PQ. This is PQ and parallel to AD. And we'll be applying BPT over here. Well, needless to say, the triangle has to be this. So we need to write down or mention the name of the triangle before proving it. So here in the triangle named is ABC. And what information we have? We have PQ as parallel to AB. So by BPT, what we can say that BP over PC, BP over PC should be equal to what? AQ over QC. AQ over QC. So this is we have used this information. Now check for the second relation. We have PR parallel to BD. So looking into PR, this is PR parallel to BD. So we'll be applying BPT again, but this time in this triangle, that is triangle here is BTC. So let's say if I write, this is in triangle BCD, right? This is triangle BCD, and the parallel line here is PR is parallel to BD. So from here also we can say that BP over PC is equal to what? DR over RC. DR over RC. Say I mark this as equation 2, this being the first equation. Now what you can observe from these two equations, you can see that they have the same LHS. Look into the LHS part of equation 1. This is BP over PC, and this is also BP over PC. So from 1 and 2, right, from these two equations, what we can say from 1 and 2, we can say that BP over PC, that's from 1, is equal to D. No. Their LHS are equal, so we need to equate their RHS. That is AQ over QC should be equal to DR over RC. Now we have obtained this relation, and this belongs to which triangle? This triangle. The relation we just obtained belongs to this triangle. That means, let me show you, we have AQ over QC is equal to DR over RC. So by converse of BPT from here, right? From here, what we can say that, therefore, by converse of BPT, this is converse of BPT, we can say that QR is parallel to AD. And what's the converse of BPT? It says that if a line divides two sides of the triangle in the same ratio, then this line is parallel. So we got this line as parallel. This is what we need to do. In this question from the chapter similar triangle, we are given if in the figure AB is parallel to DE, so that means which is AB over here. You can see this is AB, right? So this line AB, line segment in fact is given parallel to DE. These two lines are given parallel. AB is parallel to DE, right? That's the first information we have. These two are parallel. And further, we can see that even BD is parallel to EF. So where is BD? This is BD. This line is drawn parallel to EF. So these two are also given parallel. Now what we have to prove here, let's check. We need to prove DC square of DC. This means this is used twice is equal to CF. CF is, yeah, this is C to F, this part, into AC. AC is this whole thing. So we are going to use the concept of similarity and not BPT in proving this. Let's begin with this thing that here these two lines are given parallel. So by alternate interior angle, I can say these angles, say 1 is equal to angle A and angle 2 over here is equal to angle B. One more time I should write angle A is equal to angle A and we have angle 2 is equal to angle B. So we can see the triangles are similar, right? That is triangle ADC is similar to triangle. That's not ADC. That's okay. Take the triangles in this manner so that we can use their proportionality. That means I am starting with a triangle. I took CDE is similar to C corresponds to C and D corresponds to A as for the figure and E corresponds to B. So we can write their sides proportional and for the proportional I take the side CD over CA is equal to, let's say, we are going to take CE, that is CE is corresponds to what? BC. So this is the first equation we got. Now using the other relation which is given regarding the parallel lines, we were given one more pair of parallel lines equal, that is this is CEF, right? EF is drawn parallel to PD. So here too also we can say what? We can say this angle, say 3 is equal to angle 4 and likewise angle 5 is equal to angle 6. So even these two triangles are similar. Even we can write these two triangles similar. So the triangles here is, if I start with CFE is similar to, here C corresponds to C, right? C, D and B, right? And reason here is that is a similarity. We have proved two angles equal. So here also we can take the proportionality. Let's say if I take the first two letters, say CF correspond to what? CD. CD is equal to, on the other side, we have CE. CE corresponds to what? CB. Right? Say this is equation 2. Now check from equation 1 and 2. Look into the equation, that the equation 1 and 2. This is, their RHS are same, right? We have the same RHS. So we can equate their LHS. For equating LHS, what we can write? We can write CD over CA from 1 is equal to CF over CD from 2. Now, what in case if I do cross multiplication here? So CD multiplied by CD is what? CD square, and this side it is CF into AC. So this is what we need to prove over here. We got it. That is DC square is equal to CF into AC. So we'll not be using BPT in this case. In fact, it can be done easily by similarity condition. In this question from the chapter triangle, it says in the given figure angle A is equal to angle 1 is equal to angle 2. We are given this angle 1 is equal to angle 2. But I can see further that even the triangle NSQ, so where is triangle NSQ? This is triangle NSQ, right? This is triangle NSQ. This is given similar to what? MTR. So this triangle MTR, these two triangles are given similar. Now, what we have to prove here that the triangle PTS, this is triangle PTS, it is similar to this triangle PR. It should be PRQ, right? It should be PRQ. This would be triangle PRQ. Now, to prove this, what we are going to do, now we can figure out from here that first thing, we have angle 1 is equal to angle 2. So I'll start with this. That is in triangle PST, we have angle 1 is equal to angle 2. So from isosceles triangle property, we can say that PS is equal to PT. That is angles opposite to equal sides. Further, we can see that these two triangles are similar. So we can write their corresponding angles as equal. So by that I mean to say I can write angle Q is equal to angle R, right? So this is I can write angle Q is equal to angle R, and that's because these are triangles are similar, right? So here triangle NSQ is similar to the triangle MTR. Now look into this triangle first. Just consider this triangle. I'm talking about this triangle. In this triangle, what you can figure out that we have actually two angles equal, right? This angle is equal to this angle. So we can write their opposite sides equal. That is, I can write PQ is equal to PR. PQ is equal to PR. So this is equation 2. Now we are going to use this equation 1 and the equation 2. So on dividing these two equations, what do we get? We get PS over PQ is equal to PT, right? This is PT over PR. So I divided these two equations. Now you figure out from here that after dividing these two, what we get? We get the sides of these two triangles proportional. Let's understand. We got this over this, right? Let me show you once again. We got this over the bigger side, that is, this is equal to PT over PR. And we have this angle as common. We also have angle P is equal to angle P. That's common. So from these two, what we can say, the triangles are similar. Therefore, the triangle that is PTS is similar to triangle PRQ. And that's by side angle side congruency. That's how we will do this question.